Okay, so here we are again, 22.2, saturated and unsaturated fats. This wasn't in the book, but it fits really nicely since we just learned what saturated and unsaturated mean. So first off, you might want to pause the video real quick and copy down the fact that fats are stored as triglycerides, which is a glycerol polar part of the molecule with 3 long hydrocarbon chains attached to it. And that can then be broken down into saturated and unsaturated. So we'll go into saturated fats. Now what I want to do first is I want to draw a picture of a saturated fat. Now it's a kind of a cartoony little picture. This is going to be kind of the polar glycerol head of the molecule, okay? And then it's got 3 long hydrocarbon chains. Now remember, saturated means full of hydrogen, which means it has all single bonds. So these hydrocarbon chains have all single bonds. And if you remember back in 22.1, a skeleton structure of a carbon chain looks kind of like a zigzag. When they're all single bonds, they have that nice tetrahedral angle all the way down, 109.5 degrees all the way through. Okay, so that reaches back to chapter 8 with that 109.5 degrees. Okay, so it doesn't really matter how long the tail is, okay, or these little branches that stick off, but there are 3 of them. And they have exactly the same shape because they all have single bonds. So they're in this nice uniform shape as they go down here. Okay, so now let's talk about saturated fats and give you some facts about these before we move on to unsaturated fats. Okay, so again, all single bonds because they're full of hydrogen, okay, saturated. They have a uniform zigzag shape. Uniform zigzag shape. Okay, so very much the same shape in these 3 chains. And because of that uniformity, they can pack really closely together. Okay? Can pack closely. Now, when things can pack really closely together, what physical state are they at room temperature? I mean, think about that. If you can smash those molecules really close to each other, they're going to be more dense, and that's going to make them solids at room temperature. So saturated fats are solids at room temperature. Solids at room temperature. Now, most fats that we work with in our kitchens are a mixture of saturated and unsaturated, okay? But if it's purely just the saturated part, it's going to be a solid at room temperature, okay? An example of that could be butter. That's going to be mostly saturated fat, okay? And then we're going to talk about their health, okay? Saturated fats can also pack closely together inside our arteries, and that's not super good for us, okay? If they can pack closely, then they can build up over time, and that causes a lot of health problems, okay? So these are the unhealthy fats, okay? Unhealthy fats. So we want to reduce how many of those are in our diet. It's not an all or none kind of thing, but reduce, okay? Everything in moderation. All right, next page. Or not next page, next type of fat, unsaturated fats. Okay, unsaturated. We're going to draw this, and it's a little bit more complicated, so it takes up a little bit more space, but you can always, write around your picture after you've drawn it. So we still have that glycerol portion at the top of the molecule, okay? Now we're going to go into the chains, and unsaturated means that we don't have just single bonds. And in fats, it means we have some double bonds. We have a double bond in each one of those hydrocarbon chains, okay? Sometimes there's going to be more than one double bond. But what a double bond does is it changes that zigzag shape, okay? So I'm going to draw this out. I'm going to just do a couple zigs here, and then I'm going to turn this one into a double bond by just adding another line. And if this came in from the left side, at the other end of the double bond, it's going to go out on the left side. And just kind of add a few more zigzags after that double bond, okay? Now the next tail, I'm going to do that double bond in a different place. So something like that, okay? And then this one, I'm going to do it on a zig instead of a zag. Ooh, and I'm gonna run out of space, but that tail would continue on. Okay, if you have more space on your paper, add more zigs here. Okay, now if we look at this again, unsaturated means has double bonds. When we're talking about fats, it has double bonds, not double or triple, it's doubles. Okay, has double bonds. Okay, so it has, those double bonds causes kinks in the structure. Okay, so these are kinky fats. I love my nerdy chemistry jokes, so I hope that you laughed on that one. Okay, so kinky fats. All right, causes kinks in the structure. They cannot pack closely. They cannot pack closely. Okay, now they're still really large, so they're going to be like tangled up with each other, but they're not going to pack really closely to each other like they do in saturated fats. So because of that, what physical state are these at room temperature? And hopefully you're thinking liquids. So these are liquids at room temp. Liquids at room temperature, okay? And because of that, they cannot pack closely in our arteries, and that makes them healthier. So an example of this type of fat would be oil, like vegetable oil, olive oil, avocado oil, whatever oil you're using, okay? And these are the healthier fats for our diets, healthier, okay? So that's part of saturated, unsaturated organic chemistry. If you want to learn about trans fats, there's going to be another short video about trans fats in the rest of organic chemistry in a nutshell part of the modules. Okay, so hopefully you enjoyed that. This is going to be the end of chapter 22 when we're talking about our 2020 coronavirus situation here. We're going to have to zoom past 23, go straight into nuclear chemistry to get some of our essentials covered. But if you're interested in more organic chemistry, please see the organic chemistry in a nutshell module and more videos. Thanks.